Okay, so lots of you are done with number one, am I right? What's the order pair for number one? 2 comma negative 1. Yeah, it's probably not too bad. You multiply that bottom equation by 2, and then solve by elimination is a lot quicker. Okay. So now go ahead and give number 2 a shot.
You have to use 2 equations first.
If you're stuck on number 2, how do you guys do it? Yeah, take 2 equations. You need to eliminate a variable. It's either x, y, z is your choice. Then you need to switch it up. Take another 2 equations and eliminate the same exact what? Variable. And now you're down 2 by 2. Then if it's 2 by 2, you can do the same as number 1. Okay, so. So what variable do you guys eliminate first? Z. Which 2 equations?
1 and 3.
1 and 3. Okay, so 1 is 2x plus y minus z equals negative 2. So you eliminate z. So now you guys have what? 3x minus 3y equals negative 1. And then what's your next 2 equations? 2 and 3. So let me write over here. So 2 is x plus 2y minus z equals negative 9. X minus 4y plus z equals 1, right? Okay, so the z's are gone. So now you have 2x minus what? 2y equals to negative 8. Now what are you going to do next?
You're going to set the equal. You're going to do the
What do you want to multiply
elimination method.
this by what?
By 2.
By 2? And this side by?
Negative.
Negative 3. Okay, so after that, we're going to get 6x minus 6y equals negative 2 for that side. Yes or no? And then over here, we get negative 6x plus 6y, right? Equals to what? 24. Oh my, oh my. This is 0 equals what? 22. Is that ever possible? No, no solutions, okay? Okay, there you go. So that's algebra 1 or algebra 2? I forgot.
Well, 1 is 1 and then 2 is 2.
Oh, yeah? Okay. Yeah, it doesn't really matter. That's algebra. So here we go. As you can see, ready? The 2 by 2 is a lot quicker algebraically. Would you agree? The 3 by 3, if there are solutions, it will take a little bit longer because then you have to go back and plug it back all in. Now, matrices is one of the ways that will help us solve all of those. Okay. So first, definition of matrix is. I know it does make me think of the movie. Okay. Matrix is defined as a rectangular array of numbers. Each entry is denoted as A subscript I and J. And then I, where I is the row. And J is the column that it is in. Okay. So let me give you this example. we're going to have a rectangular box. And so matrices in your book, they usually denoted this big old bracket and with a bunch of entries in the middle. So we are going to try to have row 1, row 2, all the way, row I, and then row N, okay? Same thing with column. We're going to have column 1, column 2, skip a few, column J, and skip a few more, and column N, okay? Okay, so now each entry is written like this. If it's the first row in the first column, we normally write A, 1, and 1, because that's one row, first row and first column. Now over here, where it says row 1 and column 2, we're going to write A, what's the 2 subscripts? 1 what? 1, 2. You're right, okay? So A, 1, 2. Okay. Then where the J column is, we're going to write A, 1 what? 1J. And then the nth column. We don't know how far it goes out. So we're going to write A, 1 nth. Same thing with the row 2. Okay, so this is now A, 2, 1. Oops, 2, 1. Okay. Then A, 2, what? 2, 2. Okay, skip a few. A, 2, J, and then A, 2, N. Okay. And I'm going to skip a few of these just to demonstrate that it can go on forever. Then this one, because the row is I, so this is really I, what? 1. Then this is I, 2. Skip a few. I, J, and then I, N. Okay. Then the last row, similarly, is A, N, 1. A, subscript, N, 2. Skip a few. A, subscript, N, J, and then A, N, N. Okay? So that's how we read them. So the subscript tells us where to go. Augmented matrix. Let me know if I'm going too fast. How was your break?
Not great.
Yeah, thumbs up, not great. Why?
Nothing.
You can't say not great and not.
Yeah.
Oh, to Brady? To Brady, you see?
Yeah.
Did you guys have a bet? Like someone cleans in someone's, room or car or whatever? No? Okay. Augmented matrix. A matrix used, okay, to represent a system of linear equations. Variables must be on the left side. And constants are on the right side. And our next vocab is coefficient matrix. So we're going to use both of them on the bottom. Coefficient matrix is an augmented matrix with only the left side. So example 1 says, write the augmented matrix of the given system of the equation. In writing matrices, we don't actually use the variables, we just use the numbers. So here we go. This is a 3 by 3. Would you guys agree? Some of them are missing, but that's okay. So an augmented matrix, remember, it says here, you have 2 sides. So again, you will start with something like this, and it ends with something like this. Because it's an augmented, you need both the left and right side. Okay, so like that. The bar divides the left and right. So on the left-hand side is where all the coefficients of the variables go. So you have a 6 for x, it goes in order, always put in order, x, y, and z. 2 for y, and what is representing z? -1. Okay. Now on the right side is where the coefficients go. So that one equals to 0. Now I got what for x on the second row? 1. 1. Well, the last one doesn't have 1, so you have to write what? 0. And then this equals to 4. Then this is 2. I don't have anything for y, so what do you write? 0. And then 5 equals to 2. That's what an augmented matrix is. Easy peasy. Now, the coefficient matrix, y'all, it's just what? What's a coefficient matrix? Yeah, just this right here. Can you guys see that? I don't need the right side. Okay, so the coefficient matrix is a lot easier. Most of the time, though, you're just going to need augmented. Okay. Next vocab. Okay. Who already knows stuff about matrices? Okay, you guys are, where do you guys learn it from?
Summer and a little bit over break because I thought the first page of it was weird.
Oh.
Yeah. In other words, I started at that.
8th grade?
8th grade.
Just for fun?
Well, my teacher, we were doing systems and equations, and then he's like, oh, this is an easy way. I'll teach you briefly about it. So he taught us a little bit about matrices.
Cool. I think it's in your SAT or ACT. I forgot which one. On the what? ACT. Definitely on the ACT. So there you go. Okay. And it's definitely on your SBAC, because I know lots of you guys are sophomores and juniors, right? Sophomore, you're going to take it next year. Juniors, take it this year. It's definitely on your SBAC. Okay. Okay, here we go. Reduce row echelon form. Okay. Here are the conditions. There's a few. How do we do it? Conditions are, number 1, entry in row 1, column 1 is a 1. And leave some space on the left side because I need to demonstrate, okay? And zeros below it. Okay. So what do I mean by that? Entry in row 1, column 1 is a 1. So that right there is a 1. And zeros below it. Let's make it 3 by 3. There you go. Like that. That's what it means for condition number 1. Condition number 2. The first non-zero entry. The first non-zero entry in each row after the first row is a 1 and only zeros below it. Okay, so what do I mean by that? So here we go. So we fill in our first column, okay? Let's say that I'm going to try to solve for a 3 by 3 matrix C. So You have the right side and the left side. Now it says here, the first non-zero entry in each row after the first row is a 1 and only zeros below it. That means it's right here, okay, like that. So what are left here? This is whatever variable I can have. It can be 0, it can be 1, or it can be any other number. Let's call it A and B. Okay, A and B can be anything it wants it to be. So we got 1AB, then we got 0, 1, and let's call this C. Okay, again, A, B, C can be anything. It can be 0, it can be 1, it can be negative, it can be fraction, it can be decimals, it can be ugly, it can be pretty. Okay. Then what's happening is any row that contains all 0 is to the left of the vertical bar, which is that blue bar, okay, must appear at the very bottom. Okay. So I think you're gonna see a lot of this in matrices or movies, you know, a lot of times. What do you see is like a bunch of what? Ones diagonal. So that's what it means on all of those. So this is now a 1. So anytime you see a reduced row echelon form, the diagonals all have to be 1. Now the third condition is what we just said. If you have all zeros, guys, it has to be at the very, very what? Bottom. Okay, any row that contains all zeros to the left of the vertical bar, which is the blue one I have, must appear at the bottom. Okay. So when we are reducing it to row echelon form, that's the form that we're getting ready to solve. Now, what do we put on the right-hand side? Any number that we want to put, like D, E, F, because I haven't used those, okay? Where, what on earth are A, B, C, D, E, F? Where A, B, C, D, E, and F, if there's more, belong in the set of all real numbers. Have I introduced the E, the back of the funky E looking symbol? Yeah, so that belongs in the set of all reals. Next is inconsistent, is when the system of the equations don't have any answers or has no solution, okay? So inconsistent is when the system of equations don't meet. That means when you graph it out, they don't intersect, okay? If when you graph it out, they don't meet, what do we call it? AKA? What kind of answers are they? No solutions. Okay. Well, if that's inconsistent, what's consistent? Yeah, when you do have solutions. Okay. So consistent is when your system of equations have solutions. Sometimes there's more than one. Okay. When do you have an infinitely number of solutions? When would that happen? Remember, sometimes you have one solution, right? One set of solutions. Like number 1, your set of solutions were, what was x? X was 2, right? So 2 comma negative 1, that's one solution. It meets one time. When would you have an infinitely number of solutions? When there are, yeah, the same line, when they all line up one on top of another, okay? So that's when you will have infinitely number of solutions. All right, here we go. Example 2. Okay, so this one, it's easy, but it's confusing because of the language. Okay, example 2, write the system of equations corresponding to each augmented matrix. Then perform the indicated row operations on the given augmented matrix. So I'm giving you, for example, I have 2A. I'm giving you a 2 by 2. So on the left side is 2 comma negative 4, 3, negative 6, and it equals to negative 4 and negative 5. It says write the system equation, okay, corresponding to that first. So that's the first one. So how would you take this matrix and write it as a system of equations? G? That's right. Nice. Okay, so 2x minus 4y equals negative 4. Because it's a 2 by 2, so you only have x and y. If it's a 3 by 3, then you have z. And the second equation of the system is 3x minus 6y equals to negative 5. So that's the first sentence asking us to do. Then perform the indicated row operations on the given matrix. Okay. So here's what they want us to do. Okay. The new matrix, R subscript 2, this big capital R is the new row. Okay. And this wants us to change in this way. So are we changing the first row at all? Are we changing the first row at all? No. Okay, so this big capital R subscript 2 means I'm only changing what row? Row number 2. So the first one will stay exactly the way it is. So what does it want us to do? It says second row will be changed in this way. Take negative 3 times small r subscript 1. What do you think that means? Row 1. Add row 2. Okay, so here's how it's going to work. And I'm going to need like big space to write everything out for you. Okay, here we go. So we have this bar, vertical bar. First row, I'm not doing anything. Would you guys agree with that? Yeah. Now row 2 is where it's going to change. It says take negative 3 times the element or the entry from row number 1. What's the element on row 1? Row 1 is this one, right? Would you guys agree? So that has a 2. See this right here? And then add the value from row what? 2. Okay, so that's what it's asking you. So each entry has to be done like this. Okay? So row 2 is being changed in this way. Negative 3 times the entry from row 1. At the same time, I need to add the entry from row 2. And that's the first new value of row 2. Then we are going to have the same thing for the second entry. We take negative 6, which is what it currently has. I'm sorry. I need to start negative 3. Times entry from row 1, which is what? No, negative 4. Negative 4. And I need to add the entry from row number 2, which is negative 6. We're going to add them all up, but right now, that's what we're going to write down. And then same thing for what it equals to. So negative 3 times what? Negative 4. Add what? Negative 5, okay? And our answer, our final answer, we have to add it all up. So here we go. Someone give me that. The final answer shouldn't be that big anymore because I don't need to do all the work. The first one is the same. 2, negative 4, negative 4. Okay. Negative 3 times 2 plus 3. What is that going to give you? Negative 3. And then negative 3 times negative 4 plus negative 6. 6. Okay. Negative 3 times negative 4 plus negative 5. 7. So that's your new matrix with the change with the operations. Okay. Any questions at all on how we did that? Okay, you're gonna to get the reduced row echelon form, you have to perform a bunch of these. Okay, so this example is just kind of slowly teaching you guys how to do it. Okay, so B, I'm asking you to change 2 things. Yes or no? Yeah, row 2 and row 3. But let's first write the system equations. Okay. What variables are we using? X, Y, and Z. So 2x. What else? Minus 3y plus 4z equals negative 6. Then negative 5x minus 6y minus 4z equals negative 6, negative 4x minus 3y plus 5z equals to 8. So that's the first sentence of our instruction. Okay. Now the next one, we need to change 2 of the 3 rows. So the first one, I might be out of space. I'm going to need to write smaller, okay? The first row, are we changing it at all? No. So I'm going to write 2, negative 3, 4, vertical bar, 6, negative 6 back. Okay. How are we changing the second row? Take 2, okay? Take 2, multiply the value of row number 1, which is what?
4.
Which is 2. Then add the value from row 2. Okay. So we're going to write this down. Here we go. Take 2, which is what it has us to do. What's the entry of row 1? 2. Okay. Then I need to add the entry from row 2. What's the entry from row 2? Negative 5. And do that throughout, and then we can do the addition later. Write everything down. Okay. Same thing here. I'm going to take 2, multiply the entry from row 1, which is what? Negative 3. I need to add the entry from row 2, which is what? Negative 6. Same thing with the column 3. 2 times, fill it in. 2 times what? 4 plus what? Good. Over here, 2 times what? Negative 6 plus what? Negative 6. And we'll do the math later. Then this third row, we're going to take 2 times what? What? Remember, 2 times row 1 entry, which is what? What's row 1 entry? Amanda, can you hit the keyboard for me, hon? What's row 1 entry? Remember, this is row 1, y'all. This is right here. This is row 1. These guys should be exactly the same. Those guys should be exactly the same. So what goes in there? 2 plus row 3 entry, which is what? There you go. Okay. So 2 times. Give me row 1, please. Negative 3 plus row 3 entry, which is negative 3. Then 2 times row 1 entry, which is 4 plus what? Negative 5. Then last one, 2 times. Give me row 1 entry. Oh, it's positive? Oh, you're right. Thank you. Good eye. Okay, row 1 entry for the last one. Negative 6 plus row 3, which is positive 8. Okay? All right, let's do the basic math, and then we can put it back in our 1 normal. Remember, I'm writing it all out, but when you get really, really good, you don't have to do a lot. All of that is like going to be in your brain. So go ahead and compute the math and let me know. The first row is easy. I can tell you what they are. So the first row stays exactly the same. Am I right? So 2, negative 3, 4, and negative 6. Someone give me row 2 entries. What is it? Negative 1. What else? Negative 12. 4. Good. Are we at row 3 yet? What's row 3 entries? 0. Negative 9. 13. Negative 4. Someone confirm those for me. Yes, perfect. That's how we change them. Okay. Okay. Okay, let's see. We have 5 minutes. Let me see if I can finish. Okay, I think example 3 is only 1 question, right? Yeah, okay, let's do it. We have time for example 3. Here we go. All right, the reduced row echelon form of a system of linear equations is given to us. Can you see that all the zeros is at where? On the bottom. Okay, that's always the case. Write the system of equations corresponding to the matrix that's given to you. Use x, y, or x, y, and z as variables. Determine whether the system is inconsistent or consistent. By the way, consistent means it has answers or no answers? It has answers, okay? If consistent, give me the answers. Okay, here we go. There's a lot. First, it wants you to give me what? A systems of linear. Well, can you see the last row is all zeros? What do you think it means? Is it even there? Technically, I can write 0x plus 0y plus 0z equals 0, but does that, yeah, it doesn't really matter. So guess what? I would only use, I don't need the third row when I'm writing it. So I would have 1x. I don't have any y. Can you see it? So can I just write straight 4z equals 4, okay? Then the second row has no x, but how many y's? 1y plus 3z equals 2. Technically, there is a third row, but they're all zeros, so I don't need to write all zeros out. Okay. So that's the first half. Determine whether the system is consistent or inconsistent. How do you know? Should we start solving? Yeah, okay, let's start. It doesn't say how to solve, so you can solve it any way you wish. How do you want to solve this? Okay. Can you see that over here is very easy for me to isolate x by itself? So I can go, hey, x is 4 minus 4z. Yes or no? Okay. Over here, I can easily isolate y. Yes or no? That's 2 minus 3z. But now what? What would you do? This right here gives you a hint. Anybody know what that means? Remember, 0x plus 0y plus 0z equals 0. That means 0 is equal to 0. What does it mean? For,
All of the solution.
yeah, that last row is kind of funky, don't you agree? Okay, so that last row, guys, okay, remember, x equal to, okay, so let me talk to you about this. X equal to 4 minus 4z. Y equal to 2 minus 3z. That means both x and y are depending on z. Okay? But this last row tells me that z can be anything it wants to be. That's what this one, right? Because 0 equals 0 means it can be anything. Okay? It can be negative 100. It can be a half. It can be a radical 5. Okay? So this last row, class, means z is any what? Any number, any answer you want it to be. So this is going to have multiple answers. It's going to be consistent. Okay. And how would you write the answers if it's consistent? You write it as a set of answers. Z is any real number you want to pick. Okay. Then X is just dependent on Z, which you don't need to find them because you don't know exactly what Z is supposed to be. And that's it.